Hi guys, in this video we have to segregate a linked list into two parts. Okay, so first part should include even nodes and the second part should include all the odd nodes. Okay, so basically let's say we are having a linked list 1, 4, 6, 5, 8 and 7 and take one more 10. Okay, so this is our linked list and we have to segregate. We have to perform segregation on this linked list. Okay, so basically what we have to do, our output should look like this: 4, 6, 8 and 10. Okay, after that 1, 5 and 7. Okay, so we have to return this node. We have to return the starting point of this linked list, and this should be our linked list. Okay, so we know what we have to do, but how we are going to achieve it, we don't know. We don't know how we are going to achieve it, but we will simply focus on our aim. We will focus on our aim. What is our aim? We have to get all the even nodes and then we have to connect all the odd nodes. This is our aim. Okay, so we have to get all the even nodes. So we will try to focus on getting all the even nodes and then all the odd nodes. So what I am going to do, I am going to create two nodes. First one is head even head and second one is odd head. Okay, these are two empty nodes. Let's say this includes -1 and -1. Okay, so these are the starting point of that linked list, and now I am required even tail also, because head represents the starting point and tail represents the ending point. So this is required odd tail. Okay, so I have created a node and odd head and odd tail is pointing to its, and even tail and even head is also pointing to a node. I have created two different nodes, empty node. Okay, now I will start traversing my linked list. I will start traversing my linked list. I will get 1. I got 1. So 1 is odd. I know 1 is odd. So what I have to do, I will attach all the odd nodes in this section and all the even nodes in this section. Okay, so I got 1. So 1 should be attached just after tail. Okay, so tail represents the last node. And when one more node is coming, so that node can be appended just after the last node. So odd tail represents last node and 1 is odd. So we will write 1. We will attach 1 just after odd tail and shift that odd tail to its next. So that odd tail should represent the last node, because tail represents the last node. Understood now? Tail is always representing the last node. So we have shifted odd tail to its next. Okay, that's good. Now we got 4. So 4 is even. So same process. We will attach that 4, this node, just after even tail, and then shift even tail to its next. Okay, this is cool. After that I got 6. So 6 is also even. So again we will attach 6 just after even tail and shift that even tail to its next. Okay, I'm going to write exact same code which I am doing. What we have done till now, we have created even head and even tail which were pointing to -1 initially, and odd head and odd tail which were also pointing to a node -1 initially. Okay, then we started traversing our linked list and we are checking whether if the node is 1, if the node is odd, then we are attaching that node just after odd tail. If let's say now it's turn for 5, so 5 is odd, so we will attach 5 just after odd tail. And then shift odd tail to its next. Okay, that's cool, very cool. After that we got 8. So same procedure, 8, then shift even tail to its next. Easy. After that we got 7. 7 is odd, so attach 7 after odd tail odd tail, and shift odd tail. After that we got 10, so 10 is even. So yeah, and then shift even tail to its next. So this will be our final output. This will be our final output after the looping, after traversing the whole linked list. Okay, so even head is representing -1, odd head is representing -1, even tail is at the last, odd tail is at the last. Okay, now let's imagine, not imagine, let's observe our answer. What our answer should look like: 4, then 6, then 8, then 10, then 1, 5 and 7. This is our output. This is our output. Okay, so we can see we got 4, 6, 8 and 10. 4, 6, 8 and 10. Yeah, we got it. But 10, the next node of 10 is 1. So 10 is attached to the 1. So we will attach 10 to 1. How we are going to attach 10? We will write simple code. Even tail dot next should point to odd head dot next, because odd head is representing -1. We are not considering -1. Okay, so what we will do, odd head dot next should be attached with even tail. Yeah, that's good. So what will be our output? -1, 4, 6, 8, 10, 1, 5 and 7. But this -1 is also not required. So we will simply return even head dot next. Simply return even head dot next. What this will do? This will return 4, 6, 8, 10, 1, 5 and 7. 4, 6, 8, 10, 1, 5 and 7. We got our output. So let's write the exact code which I said. Okay, and we will see some errors also. Not compilation error, some logical errors. I will explain you with one more example why we are getting those errors. Okay, now what I have to do, I have to create a node, empty node, which is even head. Simple, equals to new list node. Easy. This is the initial process. And then again create a node which is even tail, and these both nodes are pointing to a same node, so even head. Initially both are pointing to -1. Okay, same process for odd one. So odd head equals to new list node, which is initially -1. Easy. List node, this is odd tail, the same process. Okay, now so odd head. Okay, now both these are pointing to a single node. What you have to do, I have to traverse the whole linked list. Okay, so let's create another node which is just copy of head. Okay, so I am not touching head. I will just keep head at its original position. Okay, so what I will do, I will create another node which is just pointing, which is just placed at the position of head. Okay, now what I will do, I will traverse. I hope you guys know how to traverse linked list. Basically, we will check until the this temp node does not become null. If this temp is null, then we can simply determine that we are placed at the last of our linked list. Last of our linked list. Okay, now what I have to do, I have to check whether this node is even or odd. So val %2 equals to 0. If it is even, then if condition will work. If it is odd, then else condition will work. Okay, so if it is even, so in case of even, what we have to do, what we are doing, in case of even, we are putting that node just after even tail and shifting even tail to its next. So if it is even, so what we have to do, even tail dot next, not next, should be equals to this temp, and then simply shift that node to its next. Yeah, and it's the same process for odd one, exactly same process for odd one. Okay, now and move temp to its next for traversing the whole linked list. Okay, now after traversing, what we have to do, firstly we will attach this 10, means firstly we will attach even tail to odd head dot next, because if we will attach even tail to odd head, then what will happen? If 10 is attached to -1, then this is not required. Nah, this is not required. We are requiring 1. We are requiring 1. That's why we are taking next of odd head. Okay. So what we have to do? We have to simply write even tail next should point to odd head next. Simple. And then what we have to return? Odd, not odd, even head next. Because even head is representing -1. Even head is representing -1. We are not requiring -1. We are requiring just the next node of even head. Okay. So let's submit the code and check if there is any compilation error. No, there is no compilation error. Let's submit the code. Okay. We will get some errors. We will definitely get some errors. Okay. Okay. So it is saying wrong answer. This is saying wrong answer. Okay. But we are not required wrong answer. This should give us runtime error. This should give us runtime error. We are getting wrong answer. So let's see where is the problem. Temp is not equals to null pointer. ठीक है. Okay, this is good. Even tail. Okay. Yeah. So basically, what we have to do, we have to. I will explain you. Let's say we are having linked list. We are having one more linked list. I will explain you with one more linked list. Okay. So let's say 1, 5, 6, 7, 22, and 24. Let's say we are having this linked list. Okay. So basically we are going to again perform the same actions. Okay. So odd head, even head. These are represented by -1 and -1. Okay. After that, we have to traverse this array. This is 1. So 1 is odd. So we will attach 1 here. After that, this is 5. So 5 will be attached here. Okay, now 6. So 6 will be attached here. After that, we got 7. So 7 is attached here. After that, 22 and 24. So 22 and 24. Okay. So we have traversed all the nodes and we got this. So what will be our output? 1, 5, 7. 1, 5, 7. 7 will be attached to 6. So 6, 22 and 24. This should be our output. Okay, we know. But let's again do the same thing. I know this is boring, but let's do it again. Okay. Now I will give you visualization. I will provide you the visualization. Odd head. And this is even head. Understood? This is -1. This is also -1. Okay. This is 1. So what we have to do? We have to attach this one after odd head. Okay. This is 5. So 5 will be attached here. Okay, we know. 6. So 6 should be attached just after odd head. After that, we got 7. So 7 should be attached here. Okay. 22. So 22 should be attached here. And then 24. 24 should be attached here. Okay. So we have traversed the whole linked list and we got this. Now what we have to do? What we are doing here? We are attaching 7 to 6. Okay. We done it wrong. Okay. We done it wrong. We are required to attach 24. We are required to attach 24 with 1. Okay, the last node of even head with the odd head dot next. So 24 will be attached with 1. Okay, sorry for that, but 24 is going to attach with 1. Okay, now we are going to do the same. 24 is going to attach with 1. Okay, now, and what we are returning? We are returning 6. So let me remove this. This is of no use. Okay, now this is of no use. We are returning simply minus. Odd head and even head are representing -1, so they are of no use. We are returning basically 6. Okay, so what will be our output? We are returning 6. Okay, 6. After that, 6 is pointing to 22, so 22. 22 is pointing 24, so 24. 24 is pointing 1. Okay, 1 is pointing 5. That's cool. 5 is pointing 7. Very good. This should be our output. You can see 1. This is wrong. Understood now? This is wrong. Initially, this is wrong. Just don't take that. This is our output. But you will see 7 is attached to 22. 7 is attached to 22. So 22 will also print it. We are not requiring this. 22 is attached to 24. 24 is attached to 1. 1 is attached to 5. 5 is attached to 7. 7 is attached to 22. You can see now. 6 is 22. Then 24. 24 is attached to 1. 1 to 5. And then 5 to 7. 7 to 22. 22 to 24. And again. Means there is a cycle. So that's why we are getting infinite loop. We will get infinite loop. Okay. So to stop this condition, what we have to do? We have to break this loop. And how we are going to break it? If somehow we can remove this point. So we will stop at 7. And these all nodes will not get printed. We will stop at 7. So basically we are getting errors because the last node, that means odd tail, is attached to some even node of even linked list. Understood? That's why we are getting error. So what we will do, we will simply cut the connection between odd tail to any node. So what we have to do, we have to cut the connection. So we will do the same thing. We will write here odd tail next should be equals to null. Okay, so we have cut the connection between odd tail and any node. Okay, now we are getting error odd tail. So odd tail should be equals to null ptr. It's ptr. Okay, now let's run the code again. Yeah, let's try to submit it. Okay, so we are getting wrong answer. This is what I am searching previously. Let's see where we are getting error. Even head, this is initialized to -1. Even tail, yeah. Odd head -1, odd tail, odd head. This is cool. Temp is head. Okay, temp is not equals to null pointer. This is also good. Temp, well, %2 equals to 0 means this is even. Okay, so we are putting that node just after even tail, which is good. And even tail dot next, yeah, this is good, very good. Okay. Here we have to write odd now. This one is for odd. That's why we are getting a wrong answer. Let's submit the code again. Now it is exact. Let's submit. Okay, so we got some errors, but we find out the way. What we have to do. We are facing some errors, but then also we find the way. We got the problem here when the odd tail is attached with any node. It can be any even node. It is not necessary that it should be attached with even tail or even head. It can attach with anyone. Okay, so that's why previously this link was present. And when we got, firstly we got 6 is attached to 22 is attached to 24. We know 24 is attached to 1 is attached to 5 is attached to 7, and we have to stop at 7. Because we have traversed all the elements, but this link was present here. And that's why we can see there is a cycle. Let me draw the cycle. The cycle is, this is the cycle. So we will start from here, then here, then here, after that here, and here. We got this cycle. Understood? So to remove this cycle, because when we will enter in the cycle, we will get infinite loop. That's why we are getting errors. So to remove this cycle, we will cut this connection from odd tail to any node. That's why we put odd tail dot next should be equals to null. Understood? So this is all about this problem. I hope you guys understood what we are doing, how the segregation process is being done. Okay, so we will meet in the next video. Until then, bye.